All right, so this whole chapter is about polynomials, and you just graphed a bunch of polynomials. So I want you to tell me some observations you've made. For example, do A and B, the pictures, have anything in common? All right, other than that, do they have anything in common?
I don't think B does.
Where does A start? Neither one of them, by the way, go through the origin. But where does A start?
Fourth quadrant.
A starts down there. That would be quadrant 3. And I don't know what it looks like because I gave my calculator away, but it starts down here and ends up here. Would you agree?
Yeah.
Now let's look at B. Doesn't B kind of do the opposite thing?
Yeah.
All right, now let's look at C and D. They do not behave that way. What does C do? Starts down here. I don't know what it does in there, but it also ends down there.
Wait, is there anywhere that?
And what does D do? Starts up here. I don't know what it does in here, but it ends up here too. I am looking specifically, read the directions at end behavior. I don't know what happens in there. I don't care. I am looking at end behavior. Now, these are very different end behaviors because for the first two, they are starting and ending in opposite directions. For the second two, they are starting and ending in the same direction. When you think about your square, it all comes back to the BFS. When you think about your squaring function, doesn't it start and end in the same direction? If you put a negative in front of it, then it starts and ends in the negative direction, right? Any even degree polynomial is going to behave that way. So if the degree of your polynomial is 4 or 6 or 8, it is going to behave exactly the way the squareds do. Now, there might be some bumpiness in the middle, jigging, dragging around, but in terms of end behavior, that's what's going to happen. So for an even degree polynomial, if it's an even degree polynomial, the end behavior, let's say with a positive coefficient, because I need to stipulate that. With a positive coefficient, on the right, it's going to go up, and on the left, it's going to go up. If it has a negative coefficient, then these would both be negative infinities, right? And then think about your cubing function. Your cubing function does this. Every odd degree polynomial is going to behave like that. So if it's x to the 5th, x to the 7th, it's going to behave just like that. Unless you put a negative coefficient in front of it, and then it's going to behave like this, right? Okay. Now, let's find the zeros in extrema. We're not going to do all these because we already know how to do it. But let's do 2a. We're going to find the zeros and the extrema in 2a. Remember, don't assume it's the origin just because it looks like the origin. You may need to expand your window if things look a little crowded. I have no idea what this looks like. But I'll tell you one thing I do know for sure. It's going to start down here somewhere. And it's going to end up here somewhere. It might cross once. It might cross 3 times. I don't know how many times it crosses. You're going to type it in and tell me because I gave my calculator away. It won't cross more than 3 times because this is the number of zeros that it has. So it has 3 zeros. Go ahead and find them. you have it graphed. Okay, that looks real bad. Why don't you set your eyes a little bit bigger? Set your eyes a little bit bigger. Kids, you don't wanna see just lines like this going up and down. You wanna see like the curve. These are polynomials. Marin?
Did you say for, if it's an odd degree with a positive coefficient, or like leading coefficient, it would be,
It's just like a cube. It's like your cubic BFF. They all behave the same way.
so as x goes into y goes to 30, as x goes into negative infinity, y goes to negative 30 and 40.
You got it. Look at my little polynomial now. Here, what's your one? Okay, Sam's got one.
But it's, x is going to be that way.
Alright, so Sam's got a picture that looks something like this. So you are responsible for finding these 3 points, those are your zeros. And then you're gonna find your relative maximum and minimum. So as you find those, would you shout them out so we can all compare?
Wait, if you,
Or are they whole numbers or integers, I mean, -4, -9?
3.
And 3? Perfect. How about the max and min? These would be relative maxima and minimum because the curve obviously goes down further and up further. Anybody have a max or a min?
Negative 2.7 and 12.6.
And what?
12.6.
Perfect, thank you. And your
1.36, and negative 20.76.
36?
76.
Thank you. Okay,
That's what I got.
we're kind of just taking everybody's word for it. Does anybody match those things? Normally, things don't work out so nice on those zeros. I mean, that's beautiful. Which, by the way, means this is a problem we'll learn how to do by hand. We'll be sketching these by hand, but that takes care of that. Oh, speaking of which, look at number 3. Find the zeros algebraically. Now, algebraically means not by graphing. So what we're looking for are the zeros. So basically, kids, you just want to solve this equation. What makes the function equal 0? Well, take a look at that. You have any thoughts on that? Take out an X. Oh, okay, well that worked out. Now what?
-3 and 2.
It actually factors, but if it didn't, you could always use the quadratic formula. But this one does actually factor -3 plus 2. So the next question, number 4, says sketch it. So let's just go ahead and sketch it. We know it has zeros or x-intercepts at 0, at 3, and at -2. Would you agree with that? We also know that it is a cube with a positive leading coefficient, so we know it starts down here, and it has to go through all of those points, and it has to end up here. So I think you know what it looks like. not hard at all. What about the next one?
Factor by grouping?
Factor by grouping sounds like a good plan. So maybe from the first two terms, take out a 2x squared and be left with x plus 3. And then from the last two, take out a negative 50 and be left with x plus 3. That has to happen, right? We gotta have a match. So we do. What about 2x squared minus 50? You can factor out a 2. I'm gonna put that out in front. And that leaves me with x squared minus 25, which factors as?
X minus 5, x plus.
Oh my gosh, life is perfect. So in terms of a sketch, goodness, easy peasy. Where are my x-intercepts? Negative 3, positive 5, and negative 5.
What about what's the 2 mean?
The 2 changes, just like it does with the parabola, changes the steepness of the curve, but has nothing to do with the zeros. Nothing to do with the zeros. Zeros come from factors. Gotta have an x to have a 0. If that had been a negative 2 out there in front of that, then I would start up here, wouldn't I? But it's another positive cube, so it's gonna start down here. I don't know how high it goes, that's a calculus problem. Comes down through here, comes down a while, comes back up, and there it is. So there's my sketch. When you are, well, maybe at the end of this year even, we might get to where we can find the maximum, minimum values, but right now, we can't. Are everybody okay with that? All right, try the next one. On your calculator, sketch this thing. You don't have to multiply it out, just type it in with the parentheses and the powers. I want you to take a look at what happens though. You might already know. But let's pretend you're surprised.
Grab those.
Yeah, don't worry about finding, you don't need to find any points. You may know what they are already anyhow. You don't need to find any points, I'm just interested in you looking at the shape. Looks normal? What does normal mean? Is it the blue one or the red one or what? Oh, no, we're graphing this one. We're on 5. We're on 5. We're graphing 5, guys. We already graphed the other ones. We know what they look like.
It's up and then it's
Yeah.
down. It's
Sorry about that. That's probably my fault. I knew what I was talking about. We're graphing number 5.
Oh, it stops on point.
How would I zoom in on just like a very specific little portion of the graph?
Well, you can actually zoom or you can adjust your window. Now, it starts up here, doesn't it?
Yeah.
Goes through that point, keeps on going. Now again, I don't know how far down it goes, but it turns around at some point, comes up and does this. Mrs. Ford, how do you know that? See that right there? What does think of your BFFs, what does a squared look like?
Parabola.
Now, this is not a parabola, okay? This is not a parabola, but it has that behavior. It has like a vertex, okay? So when you have a squared factor, that's what it does. Now, I'm not sure whether your graph shows this or not, but this one kind of squiggles through.
Yeah.
Can you see it? Why is it squiggling through?
It's just a cube.
Because it's cubed, and what do cubes look like? Squiggles. Now, does it make sense? Wait, first, how did I know it started up there?
This is positive.
How many X's are there? No,
No, there's 2, 5, 6.
there's 6. 6 is even. How do evens behave? Up, up. Unless you put a negative in front of them, evens are up, up. Think of X squared, even, up, up. If there had been a negative in front of that, these behaviors would be exactly the same, but it would have started down. Notice that when the factor is not squared, cubed, or anything, you just pass straight through it, just like a line. When it's squared, you bounce off of it, just like a parabola. And when it's cubed, you squiggle through it, just like a cube. So let's say I made this a 4. All evens are going to behave the same way. So if it's an even factor, x to the 4th, x to the 6th, it's going to behave like a parabola. An odd factor is going to behave like a squiggle. Wow. We can graph these things by hand. Let's try 6A. No calculator necessary. Listen, when mom and dad want to know what you learned today, you whip this out. They'll be impressed. What do I start with?
Zero.
My intercepts, yep, I'm gonna start with my zeros. So I've got one at 0. I've got one at -1. I might spread these out a little bit. I've got one at -1. And I've got one at 2. Would everybody agree with that? Now what's the next thing I probably better do? Count up my X's. Because I really would like to know if this is even or odd, so I know how to start it. So, how many X's do I have? I have 6, which is even, but there's a negative coefficient, so it's going to start down here, right? Now, the first 0 it encounters is this one. This one came from that factor, which is cubed. So this is going to have to squiggle through there. Tess?
Wouldn't it be if the highest power is 3, so one of it and it's negative, so one of it the other way?
X's, Tess. If you FOIL this out, wouldn't that be X cubed? Wouldn't that be X squared? Times another X? There's 6 X's up there. Now, at some point it has to turn around and connect to this dot. Polynomial functions are continuous, so everything is connected. We don't know how high that goes, we're not concerned about it at this point in our lives. It goes up and comes down. Now, what does it do when it hits that 0? It goes straight through it, just like a line. It goes straight through it. Because that doesn't have a power. It's a simple, what we call a simple or a single 0. You just hit it and go through. So then it goes down a while, and it turns around and comes up and hits that one. What does it do when it hits that one? That one came from a squared factor, so it bounces back down. Now, I always stop myself at this point and say, is that how it should be ending? Should it be ending down there? Yes. because it's an even and it started down, so it must end down, right? That's kind of a little built-in check for you. All right, try the next one on your own. Test how many x's we got all together. In other words, what's the degree of this polynomial? Uh-huh.
Wait, okay, what? This is for
What?
when the, I don't know how to phrase this. When your line hits one of like the x's, like one of the zeros, how do you know if it should bounce up or down? Like if your
If
line
it's
should
bouncing,
go
it's
up.
gonna bounce in the direction it came from. That's the only way you can bounce. Right?
Yeah, so
All right, where did you put your zeros this time, guys? All right, that's step one. Gotta know those. All right, what's the degree of the polynomial? Test told us 5. That's odd. The leading coefficient is positive 1, so it's gonna start down here. Odds start, think of your cubic function. BFFs are with us always. So it starts down here. Now, what does it do when it hits that? Comes right back down, turns around, comes up to here. What's it do when it hits that one? Goes right on through, comes around. What's it do when it hits that one? Bounces back up. Is that the way it should be ending? Yes, because it's an odd degree polynomials and odds start down, end up. Unless they have a negative in front of them. Right? There is something that's made these problems very nice. Why have these problems been so easy? They're already factored for you. Oh boy.
Hold on, Miss Fuller.
Well, I don't know, we'll save that for the next day, but
Can you
that's,
explain the endpoints, like how you know where it begins?
think of your BFFs. X cubed. Where does it start? Every odd is going to behave that way, unless you make it negative, and then it's going to turn upside down.
Okay.
So,
Yep.
with the bouncing, it just goes like in the direction it came from?
Yes, that's what bounce means, right? So when the ball bounces,
Yeah, okay.
all right, number 7, come on, we gotta get one more done. Find a cubic function whose zeros are 3, -4, and 6. Find a cubic function. All right? Well, that's not hard, right? Because if these are the zeros, what were the factors that generated those zeros? X -3, X +4, X -6? Would you agree with that? Yeah. And then we can FOIL. I lost something. And I did this in a wacky order, wasn't very organized, and may have made mistakes, so I better double check. Last comment of the day. Why does it say find A? And and that's like underlined, like that's an important little word there. What does that mean?
Is there more than one?
Is there more than one? I don't know, Sam.
Yeah, there's one.
How could there be more than one?
Um,
Because what this is telling me is, I've got an intercept with 3, -4, and 6. So I just got a cubic equation that would look like that, Katie?
yeah.
Are there other cubic equations that would contain those 3 points?
Yeah.
How many more? Billions. Sydney, what does it depend on?
The degree to each.
Oh, so Sydney's saying we could even complicate it further and put powers on these guys. Now, it does say find a cubic, so there aren't going to be any powers on there. But what do I not have here in my problem? Could there be a coefficient there? Is there any way of knowing that coefficient based on just the zeros? No. So you understand, this thing could be upside down, it could be really tall, right? There are lots of ways. All right, we'll continue that next time.
I said I had already.
And it's Friday. Last class on Friday.
Welcome back.
My 1723.
Henry, why are you so tired today?